How do features of waves relate to musical instruments? In a nutshell, musical instruments manipulate amplitude, frequency, and wavelength to create pitch and to control loudness. Firstly, pitch. Pitch depends on the frequency of the sound wave. Objects vibrating quickly produce short wavelengths, creating a high pitch, and objects vibrating slowly produce long wavelengths, creating a low pitch. In music, specific pitches are called notes. For example, this pitch is 264.94 Hz, which in music is the note B. In tuned instruments, the general idea is that something is vibrating at a specific frequency to create a note. For example, in guitars, each string has the right amount of tension and length to be able to vibrate at a specific frequency. The frequency changes when the strings are pressed down upon. In a xylophone, it's the bars that vibrate. In wind or brass instruments, it's the air and the instrument. From Year 8 music theory, you know that 3 notes create a chord. You just heard an A chord comprised of A, C sharp, and E. Each of these notes have a specific frequency, and if you set them out as ratios, they simplify nicely. This is what makes a chord sound good to you. The numbers are easy to comprehend, so your brain makes it sound good. Compare this to a tritone, for example A and E flat. This interval has the ratio of 1 to the square root of 2. In the olden days, they used to call this the devil's interval because no one really liked it. But listen, this is a violin's E note. This is a piano's E note, and this is a sine wave of E. They look and sound different despite them being the same pitch. All these notes have the same fundamental frequency, E, but the reason why these waves look and sound differently is because most sounds are actually not a single frequency, but a combination of frequencies, or harmonics, each with different strengths all on top of the fundamental frequency, in this case E. This is timbre, the characteristic quality of sound, independent of pitch and loudness. Now let's talk about amplitude. There's a direct relationship between amplitude and volume. Look at the sound waves of my voice. When I speak loudly, the amplitude is high. When I speak softly, the amplitude is low. See the correlation? There's a direct relationship between amplitude and loudness. Now hold on, what does this have to do with instruments? Let's observe the shape of sound waves. Normal everyday sounds, such as coin dropping, has an erratic shape, while tuned sounds, such as a piano note, has a nice slope. Instruments, along with the other jobs, also convert kinetic energy into the amplitude of the sound wave. For example, if a pianist presses lightly on a key, the amplitude will be low and the resulting sound will be soft. If a pianist presses on a key heavily, the amplitude will be high and the sound will be loud. That's how amplitude relates to musical instruments. But keys, strings, drum heads, and more are just the triggers that play the note. The body of the instrument is what makes the sound loud. Observe. That's called resonance. Resonance is when a vibrating source drives another object to vibrate with greater amplitude but with the same frequency. So basically, instruments control frequency to create pitch, and with this, make combinations of notes sound good via math. Also using frequency, timbre is produced and musical instruments have their own unique sounds. Instruments are also converters, transforming kinetic energy into the amplitude of the resulting sound wave, controlling volume. The body of the instrument also amplifies this sound using resonance.